Okay, so let's vote. Roof A, how many people? 0. Okay, roof B, 0. Roof C, almost all of you. Okay, so you guys all think C has the steepest roof. I agree. Now, how can you tell? And I said use numbers to help you justify. I don't know if you actually see the numbers here, but can you actually see how there's a grid on your pictures? Can you? And I don't know if you can see this, but there's a word here that says run. I'll say this again. And this word that says rise. Okay. Here's a rise and then a run. Rise and run. Can you actually help me calculate what those numbers are or count them for me, please? So for each of these A, B, and C, can you tell me what the run number equals to and the rise number equals to? Okay. So try that, please, right now. Okay. Try that. And if you can't see it, you can use what I have here on the overhead. Okay. Okay, let's take a look together. I'm gonna count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the rise seems to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13? Okay. Making sure I can count. Okay, the other one here, I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The run in this case is 12. And the rise, 1, 2, 3, 4, 5, 6, 7. The rise is 7. Okay. And then if you can do roof C, the rise seems to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, seems to be 14. And the run, can someone do that one for me? My eyes are getting blurry. 8? Okay. Now you may be thinking, Mr. Lee, why are we using these numbers? Who cares? Well, in terms of trying to look at the steepness of the roof, you said roof C is the steepest of them all. I agree with you. Correct. But how can we use these numbers to kind of help us determine if this is steep or not, or is the steepest or not the steepest? What do you notice about this roof C? What do you notice about the numbers when you compare rise with run? Which number is bigger, first of all, rise or run? Rise is bigger. Okay, rise is bigger. How about in roof B? In this case, when this roof is not that steep at all, what's the rise? It's 7. What's the run? It's 12. Which one's bigger? The run. So you're saying the further out you go horizontally, then you go up a little bit vertically. Yet in part C, this one is you don't go very far horizontally, but you go really high vertically. So that's how you get your steep or your steepness. Okay, now for roof A, if you take a look, the run and the rise are the same number. So that's kind of like a, well, it's just slanted. Okay, so what about saying something like this? Okay, why is roof C the steepest? Well, you can say that the rise is greater, okay, than the run. Okay, and what that means is that when you move, okay, horizontally a certain distance, the vertical move is much greater, okay? The vertical move is much greater. Okay? Who are you? I want to introduce you to a new word today. You know, on Sesame Street, they have the word of the day. On Mr. Lee Street, they have this new word of the day, okay? The word is slope. Slope measures the amount of steepness, how steep something is, okay? And we always measure steepness relative to the x-axis. So if I had a horizontal line like this, the steepness is 0, right? It's not steep at all. As you keep going up, this steepness gets larger and larger. And I'm going to show you today how we actually calculate how steep something is, or how the slope is going to be. Okay, here's the connection from chapter 5, dear friends. Rate of change, remember that? No, then you didn't do very well in the chapter 5 test, did you? Yeah, change in which? Change in the dependent variable. Very good. I'm going to say just dependent variable. I guess I say variable. Okay. divided by the change in the, which one? Independent, right. Okay. Now, sometimes, okay, change uses this little symbol. I don't know if I introduced this to you before or not. D. That's sorry, not D. Triangle. A triangle. It's a Greek symbol, yeah. So the change in the dependent divided by the change in the independent. Okay. Now, a lot of times the dependent variable is called y. So that's why the change in the y is often called, and this is triangle, or what we call delta, delta y. And the change in x is called the triangle or delta x. Okay, so the triangle in Greek terms is called delta. That's how you say it. And I can't spell it. Delta, D-E-L-T-A. Okay? Delta. Yeah, stop it. Okay? Now, before we do the next part, what do you think represents my dependent variable in those pictures of the roofs? Is it the rise or is it the run? The dependent, yeah, dependent. The rise, because it's the up and down, right? Dependent. And what's the independent then? It's the run. Okay, so ladies and gentlemen, what I'm going to show you today is that this idea of slope, which is really the rate of change, is the same thing as rise over run. Okay, so rise is your change in the dependent variable, where run is the change in your independent variable. Okay, we're comparing vertical move with a horizontal move. Now, what we're going to be doing in this chapter is I'm going to give you points on a grid, okay, a coordinate system. So here's the x, here's the y. Can you please write that down? And let me just write down two random points here and here. And we don't actually have the coordinates, so I'm going to label them as follows: the x coordinate and the y coordinate. But I'm going to label this one also an x coordinate and a y coordinate. Now, here's my dilemma, dear friends. I called the 2 points the same thing, but they're different. So what am I going to do to make them look different? Here's what I'm going to do. Okay, I'm going to, instead of calling this xy, I'm going to call this x1, comma y1. Close it. I'm going to call this x2, comma y2. Okay, so what I'm saying is this is the first point. That's why I'm going to use a subscript of 1. This is the second point. That's why I'm using the subscript of 2. And I'm going to use x1 to represent the x coordinate of the first point, x2 to represent the coordinates of the second point. Okay? Now, our job today is to find the steepness or the slope of this line. Okay? Draw this in, please. Now, how are we going to do this? What do we have to calculate? What do we do with this, the question with the roof? We found the rise and we found the run. Okay, now can you draw me where you can find the rise and run on this picture? I think if you were to draw a vertical line like this and draw a horizontal line like this, which one's the rise again? The vertical line or the horizontal line? I forgot. Vertical, good. So this here is the rise, and this one down here is the run. Okay. Now, we're going to have to come up with a formula to calculate this. Okay? The formula will involve these variables, x1, y1, and x2, y2. And then I know you guys hate formulas, so I'm going to show you an interesting way of actually memorizing this formula. Okay? Now, can someone help me out? How can I find the rise if you're given the y2 value and the y1 value? How do I calculate this distance? Yeah. Yeah, y2 minus y1. Subtract. Excellent. So can you please write here that this distance in green is just y2 minus y1. Okay, please write that down. And because this represents the rise, in the box over here, I'm going to write down y2 minus y1 to represent the rise. How about the run? x2 minus x1. Bravo. So the run is the distance or the difference between your x2 and your x1. Ladies and gentlemen, you have just come up with the equation of the slope. This is the first big thing that you need to know for grade 10 and grade 11 and grade 12 and university level math. You'll hear this word a lot, slope. Okay? Slope is equal to y2 minus y1 divided by x2 minus x1. You have to memorize this. Okay? I know this formula is on the provincial exam, but I'm making you memorize it because I'm mean and I can. Okay? I think it's so important that you need to memorize it. So how can you memorize it? Let me show you how.
Oh my gosh.
Okay? All right. You guys like songs, right? I know the things that you hear on the radio and all that. All your cool tunes from whoever you listen to. Okay? The Beat 94.5? Boom, 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 boom. No? Okay. But I don't want you to go back to those type of songs. I want you to think back to your good old preschool days. Do you remember good songs from like when you were young in preschool? Do you remember a song that has a guy in a boat? Blues Clues? Blues Clues. They had the best songs too. Yeah, Blues Clues. Blues. Anyways, remember a song with a boat? What do you do in a boat?
You
Row your boat. What is it?
Row,
Row your boat gently down the stream. What else?
Like
And then I forgot the words. Right.
mm-hmm.
Did you know? And this is a true story now. Okay. There's actually verse 2 for that song. Row, row, row your boat. You only were taught verse 1 in preschool. There's actually verse 2. There's another.
Okay.
I'm serious. Okay. I'm going to teach that to you now. So, to the song lyrics of Row, Row, Row Your Boat, okay? So, I'll say, to the tune, and please write this down. I'm serious. To the tune of Row, Row, Row Your Boat. Okay? Now, I'll sing it to you first. I will sing it to you. A free concert. And then you can write down the lyrics, and we'll all sing together. Okay? All right. So, row. No. Okay, here we go. I'm getting nervous now. Okay, so I'm going to sing you verse 2, okay, because I forgot verse 1. Oh, maybe I should sing verse 1. Okay. Row, row, row your boat gently down the stream. Merrily, 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 merrily. Life is but a dream, or whatever, okay? So here's verse 2. Here's verse 2, okay? Here's verse 2. This is the important one. Ready? Listen. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. What? Let's do it again, okay? Let's write down the lyrics first, and I'll teach it to you again. See? Math and music, they go together. Here we go. Stop laughing. This is serious. Here we go. First line. Slope equals y sub. Okay, now that little letter or number underneath, I call it a subscript, but that's too long, so I call it sub. So y sub 2. Okay? Ladies, write this down. No, you're not. Slope equals y sub 2. Okay, and the next one is minus y sub 1. Okay? And that bar sounds kind of hard to say, that bar, or divide, so I'll use the words all over. Okay? Then there's x sub 2 minus x sub 1. There you go. Quickly ask you to write down the formula on the top, okay? So sing it in your head or sing it out loud, I don't care. Slope equals y sub 2 minus y sub 1. Dun-dun. All over x sub 2 minus x sub 1. Okay, so there's your formula. Okay, I'm going to ask you to use this formula now to help me with example number 1. Find the slope of the following line segments. Now, if you need the visual and you want to draw this out, you're more than welcome to do so. But if you don't and you just can plug it into the formula, do that instead. So once again, you're given 2 points, all right? So our first point is negative 1, comma 2, and I'll draw this for you for those of you who like the visuals. Okay, there's negative 1, comma 2. And B is 5, comma 9, that's way up here. Okay? And I'm asking you to find the slope of this line, meaning find the steepness of this line. Who cares about the phone? Okay? Huh? Oh, right. Okay. Okay, sorry people online. Mr. Lee got too excited by singing the song. Let's erase this. Okay. See what you're missing when you don't come to class. You miss songs. Good times. Okay, so anyways, let's draw the line. Okay. Now, if you wanted to do this visually, I guess you could just do like the pictures of the roof and kind of connect them like this. Okay. And just count. But if you don't want to do it that way, heck, let's use the song you just heard. So remember you have 2 points. I'm just going to quietly call this one x1, y1 and call this x2, y2. Now I like to write them on top of the numbers so I know which one's which. If you don't need to do that because you can visualize it, go right ahead, don't write that down. But let me just ask you to use the formula for slope. Help me out somebody. What's y2 in this example? Call the number. 9, good. What's y1? Okay, so -2. So 9 take away -2. Okay? 9 take away -2. How about the x? x2. x2. 5. What's x1? -1. Okay, so let's go ahead and simplify this. Now, do all the numbers on the top together and the numbers on the bottom together. So 9 take away -2 gives us 11. 5 take away -1 gives us 6. And I think that's your answer. There you go. There's your slope. Okay? Just leave it like a fraction if we can't simplify it. Perfect. For those of you who like to count, if you're going to count the run. 1, 2, 3, 4, 5, 6. Oh yeah, the run is 6. And then count the rise. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's the same thing. Okay? Happy? All right. You do part B, please, on your own. Okay, if you want to draw it out, you can. If you don't, just use the formula. Okay, go. Do B, finish that one, do C, then do D. Okay, whenever you can simplify, please simplify. So for number 1B, what's -4 divided by 4? That's just -1. So that's the correct answer. Okay? Now let's do C. Okay? Once again, x1, y1, x2, y2. This one's interesting too. Okay? I give you interesting things to see. -6 take away -6 on the top. Agreed? What about the bottom then? What are 2 numbers? 3 and then minus -7. Okay. What's -6 take away -6? 0. Right. 3 take away -7. That's 10. What's 0 divided by 10? 0. What kind of line has a 0 slope? Yeah, I know it's a line. I know straight, yeah, all lines are straight. It's not slanted. So what is it? It's horizontal. So this is actually an example of a horizontal line. Now let's just double check to see if that is true. Okay. I'm going to ask you to plot these numbers out on the grid. -7, -6. Okay. 3, comma, -6. Is this a horizontal line? No. Horizontal means left and right, flat. It is. Okay. So once again, a horizontal line has no steepness, so we call it 0 slope. Okay, yeah, 0/10. Now you try part D, okay, and let's do this one together because this one's kind of weird too. Okay. Slope equals y, no, not y sub 1, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. You will be singing that tonight in the bathtub. -8 minus 5. That's -13. What's 8 minus 8? 0. Now what's this? What's -13 divided by 0? I don't know. Do you know? No, it's not 0. Okay, don't say 0. This is not 13 either. That's when you divide by 1. This is in math what we call undefined. We don't know how to divide by 0. How do you take 13 things and divide it into 0 groups? You can't. So we call it undefined. Now, think about this. This is kind of weird too. What does this line look like? An undefined slope. What kind of line does this look like? Vertical? Straight? Dude, all the lines are straight, remember? Vertical sounds better, but let's just double check. 8 comma 5. Let me plot this out. 8 comma 5. That's over here. This is point M. And then N is 8 comma negative 8. You're right. Look at this. We have a nice vertical line. So an undefined slope means that you have a vertical line. Okay? We're going to look at this idea again in a second, but I just want to show you this. Okay? Yes, Sulman.
Why is it negative 13 when I counted no?
Ah, right. When you count it, you're like, it's 13, right? But I said here negative 13. Okay. In the formula, it's negative 13 because I always take the y2, my second coordinate, and subtract the first. Okay? In the end, I don't care if you have 13 or negative 13, because when you divide by 0, you're still going to get undefined. Okay? So in this case, it doesn't really matter. All right? Okay. How are we doing okay so far? Yeah? Slope? Got it? Okay, let's try something harder. In example number 2, I want you now to do something. I want you to make the line for me. I'm going to give you some information. You make the line. Okay? So let's do this together. Slope of negative 5 over 6 with a y-intercept of 2. Okay, this part we should know from chapter 5. Someone tell me, what point am I looking at when I say the y-intercept is 2? What are the coordinates of the point? 0, 2. Good. Take your pen, put a big dot right there. Okay? 0, comma 2. Now here's the weird stuff, which is new. How do I now graph out a line that has a slope of negative 5 over 6? How do we define slope again? Not using my song, but using the words rise and run. What does rise mean? Rise is the number on top. Remember, run is the number on the bottom, right? Rise means going up or down. Run means going horizontal. So do you see how we have a number on the top, number on the bottom? Right? Top number, rise. Bottom number, run. Now what about that negative? Oh. Oh, down. Okay. So I always want you to do this, okay? Whenever you see a negative, connect it with the number on the top. Okay? So make that connection. Just make sure you know that it applies to the top. It can apply to the bottom, but in our sake, it's easier if you just apply it to the top. Because what does it mean when I have a negative rise? Go down. So what this means, the negative 5, that means you go down 5 units. Okay? And when you're running to the right. So you're running to the right. So go right 6 units. That's what this means. Okay? So when you see this fraction, which represents slope, we can use the ideas of rise over run. And in this case, the negative 5 means you down 5 units, and then you go right 6 units. So here's what you do. You start at the point that I drew, 0, comma 2. And now I'd like you to go down 5 units. So go down 1, 2, 3, 4, 5. You're at negative 3 now. And then go right 6. 1, 2, 3, 4, 5, 6. Put another dot.
So the negative only applies to the top?
That's right. The negative only applies to the top. Don't apply to negative to both the top and the bottom, because that means you have 2 negatives. And then 2 negatives, of course, become a positive. That's a different question. So just apply the negative, and I would like you just apply it to the top. And then draw on your line, okay? And once again, this is a line that goes through the 2 points, so make sure it goes through the 2 points. And then please put arrows on the end, because the arrows mean that the line goes on forever and ever and ever. Okay? All right, let's keep going. Okay? How about part B? Slope of 2 passing through the origin. What does it mean when I say slope of 2? You're like, shouldn't it be rise over run? How come I only see one number? Uh-oh. Can you change this into a fraction for me, somebody? 2 over 1, Bianca says. Good. Let's write that down. Slope of 2 means 2 over 1. Okay? So which number represents the rise? 2. Which represents the run? 1. So when I say a rise of 2, that means I'm going which way? Up or down? Up 2. Up 2 units. And when I do that, how many units do I go to the right? 1 unit to the right. Okay? Now where do I start from? 0. What's the origin mean? What point represents the origin? 0, 0. Awesome. Okay. So ladies and gentlemen, let's use this information and let's plot the line. Where's my first big dot go? At the origin, 0, 0. And now what I'd like you to do is from that dot, go up 2 units and 1 unit to the right. Up 2, 1 to the right. Now notice, dear friends, I've only drawn 2 dots. You can keep doing this, you know. Go up 2 more, 1 to the right. Go up 2 more, 1 to the right. Go up 2 more, 1 to the right. Like, you can do this forever if you wanted to. But technically, how many points do you need for a line? Just 2. Okay. Draw it in. There you go. So this is B, and the green one is A. Okay. So this idea of slope also, okay, can be used to draw out lines. How are we doing so far? Good? No good? Okay. Yes, Mehdi. For A. Sure, I'll quickly repeat what happened. Okay, so what I'd like you to understand is when you see this fraction that represents slope, okay, what that means is you're comparing the rise and the run. Okay? Because you have this negative, you could have chose to put the negative down with a 6. So I just chose not to do that. Okay, I just chose to apply the negative to the number on top, which is the 5. So that means I have a rise of negative 5. Well, a rise of negative 5 just means you're not going up, you're going down. That's why I said we have down 5 units. Is that okay so far? Okay. The bottom number represents the run, the distance that we move horizontally. So that's why I'm saying you go right 6 units. Okay, so that's what that fraction means. Down 5 units, right 6 units. That's the idea of the slope of negative 5, 6. Now, where do we start? It says that this line also goes through this point, which I call the y-intercept, which is the point 0, 2. So what I do is I first of all plot the y-intercept, and then I use this information, down 5, right 6, to then find the next point on that line. So I go down, over, next point, 2 points, connect them together, there's my line. Okay? All right. All right, let's do example number 3. Uh-oh, another new word. What does collinear mean? Collinear means they share the same line, and therefore they should have the same slope. Okay? So you know there are 3 points here. If I were to plot them all in a grid and connect them all together, they should be on the same line. But unfortunately, I didn't give you the grid, so I don't want you to do it that way. I want you to show me that they have the same slope. So here's what you're going to have to do, dear friends. You're going to have to calculate the slope between the different points. For example, you need to find the slope between R and S. Okay, so we'll do that. Then you're going to have to find the slope between the points R and T. Now do that. And then you're going to have to find the slope between the points S and T. Do that. Okay? And what should you hope in the end? If they're collinear, the answer should be the same. Okay. So I'm going to write out the coordinates for you, and I'm going to ask you to now calculate the slopes, please. Okay, so RS, there you go. Okay, you go find it out. RT, negative 5, negative 4, 4, comma 2. Go ahead and find it out. ST, negative 2, negative 2, and 4, comma 2. Okay? So can you now please go ahead and calculate the slope for each of these using the formula, and let's hope that the fractions you get are the same. Okay? Spend a few minutes doing this on your own. Okay. They don't look the same. Oh, you have to simplify. Yes, don't forget to simplify. 6/9 simplifies into 2/3 if you divide everything by 3. So 2/3, 2/3. I like that so far. What's 4/6 simplified? Also 2/3. Yay. Are they the same then? Are they collinear? Yes. So I'll say since slopes are all the same, the points, okay, the points R, S, and T are what we call collinear. Okay? All right. Okay, I'm going to try to summarize this idea of slope. Oh, before I do that, yes, Suleiman. 6 over 9 is the one in red. That equals to 2 over 3. 9. Here?
Well, lower than that. Over negative 5.
Yeah.
Over defined. Yeah, that's negative
2 minus negative 4 is 6. That's right. Okay, turn the page. Let's summarize things, okay? Summarize, summarize, summarize. Okay, there are 4 different types of slopes that you already seen. Okay, I'm going to ask you to draw a picture. Okay, I'm going to ask you to describe it. I'm going to tell you the type. Let's draw the pictures first, because I like pictures. Let's draw on the axes first of all for all these. So I'm sorry I didn't do this for you, but if you can just quickly do a quick sketch of the axes. Okay. And let's see if you can identify the 4 different types of slopes that we've actually seen so far. Okay, let me give you the first picture. It's a line that looks like this. Okay. Whee! Okay. So from left to right, this line moves upwards. Moves upwards. Okay. Now, a line like this, what type of slope do we call it? And we saw it on the previous page. If you look back to the previous page, example number 2, which line looks like it's upward sloping? A or B? Which line looks like it's upward sloping? B. What do we know about the slope of this line? It was 2, or positive 2. Okay. If you look up here, you see this one, this line AB? That was the slope of the first one. This fraction is positive. So what I want you to see is that upward sloping lines have positive slope. Okay. Because the rise going from left to right is positive. It's rise. Okay. What do you think I want to draw on the next one then? Downwards, right. So this is a graph now that moves downwards. Good. And we now know there isn't a rise, there's like a negative rise because it's going downwards. So this is what we call a negative slope. Okay, so anytime you see a negative slope, your line goes downward from left to right. And what other lines have we seen? Vertical and horizontal. Bravo. I'll do the horizontal one first. Okay. So from right to left, this is horizontal. And do you guys remember what the slope of a horizontal line is? Good. 0. 0 slope. Nothing. Okay. And the last type is called the vertical line, right? Vertical line. And this is the weird slope. What do we call this slope? Very good. Undefined. Undefined. Excellent. This is the summary, okay? Along with, once again, the slope formula. This is the main crux of this section. If you understand this stuff, I'm very happy. And of course, you want me to be very happy. Well, most of you at least. Harder. Okay, let's erase that. Okay, it says given the point A and the point B. Now, notice what's missing for point B here. We don't have this x value. We've got to find that out. Weird, we've got to find that. It says find x if the slope of the line is equal to 3. How do we find the slope of a line when I'm given 2 points? Slope equals rise over run. Sing the song with me. Slope equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. How come I'm the only one singing? I have such a beautiful voice. Suck up. Okay. Let me call x1, y1, x2, y2. So are you saying if I put on a concert, you come to hear me sing? Yes? If I charge $5, you'd come hear me sing? Moral support. I don't need moral support. I need cash. Alright, so how can we figure out the slope here, dear friends? Let's plug in the points. What's y2? -3. Good. What's y1? 9. Good. What's x2? X, yeah, just use x. What's x1? Minus 4. Let's simplify this a little bit first, okay? What's negative 3 minus 9? Negative 12? Okay. So ladies and gentlemen, you just told me that the slope of this line, given by this formula, is negative 12 divided by x minus 4. Good. But how is this going to help me find x? What other piece of information have I not used here? So what's 3? AB. The slope of the line of AB is 3. Well, what is the slope of the line? Isn't that this negative 12 over x minus 4? And isn't the slope also this 3? So I guess those things equal each other. Not x is 3, careful. But what I want you to understand here is that therefore, we're going to take this negative 12 over x minus 4, because that represents slope. And you just told me that the slope also equals to 3. So make it equal to each other. Okay? This is the key step. I used the slope formula. I got an expression. And the question said that the slope equals to 3. So make that expression equal to 3. How do you solve for x? Okay, so now I'm going to ask you to solve for x. Now solve for x. How? Isolate x? Yeah, but we got this fraction stuff. Ew, I hate fractions. By the way, what if I did something like this? If I put this over 3 over 1, what do you think you can do now? Yeah, if you like cross multiplication, do that. So I'll say now solve for x, and I'll say use cross multiplication. Okay. Remember, if it's just 3, change it into a fraction, 3 over 1. So let's go like this. Let's cross this part. What's negative 12 times 1? That's negative 12. Okay, cross the other part. What's 3 times x minus 4? Now here you have to use those algebra things. It's 3 bracket x minus 4. Oh, yeah. Oh, nasty. Oh, how do I get rid of the bracket? Distribute. Thank you. 3 times x is 3x. What's 3 times negative 4? Negative 12, yeah. Okay. How do you solve for x? Now it's algebra. Add 12, Gian says. Correct. We'll add 12 to both sides. Therefore, we get 0 equals to 3x. What's next? I want to solve for x, not 3x. Divide everything by 3. What's 0 divided by 3? That's still 0. Very good. There you go. You solve for x. Ta-da! X is 0. Okay. When open, the wheelchair ramp on a transiting bus must have a slope that is less than 1/8. Okay. Key statement. Slope 1/8. That's the key. It says the height of the bus after it kneels down is 80 centimeters above the ground. And the question here says, what horizontal distance is needed in order for the ramp to deploy correctly to allow the wheelchair passenger to leave the bus? You're like, whoa, what's going on, Mr. Lee? This is a crazy question. Okay, you see this ramp? You see how it's kind of slanted going downwards? I'm going to draw the ramp for you here, okay? Ramp. There's the ramp. Okay? Ramp. Here's the ground. Okay? And if I'm going to connect this together like this, can you look back and describe perhaps what this distance here is equal to? The distance from the ramp to the ground. I think the question told you. What's the distance? 80. Good. Okay. What are we trying to find though? It says what horizontal distance? Oops, I spelled it wrong. Distance. What horizontal distance is needed? So I'm actually asking you to find out this. This is the horizontal distance, the run. Right? Let's call that x. So your goal here is to find the horizontal distance, okay, which I call x. Sorry, Suleiman? Staying in cost? Oh, you're thinking about trigonometry. Ah. Why do you think that way? Because you see triangle, right? Yeah. No, not this time. Okay? Now, the problem with this one, it's okay though. I like your thinking. But the problem with this one is when you're doing trigonometry, the sine, cosine, tangent stuff, what do you need? You need an angle. Did I tell you an angle here?
No.
No. So sorry. Okay. Now, what I did tell you was something more important. I told you something about the slope, didn't I? What's the slope? What's the slope? 1/8. How am I going to use that information to help me out here? I said the slope of this line is 1/8. Slope is equal to 1/8. How do I define slope again? What over what? Rise over run. Good. Rise over run. Good. Now, what is the slope of this ramp going to be then? Let's say slope of the ramp. Well, remember, it's just the rise divided by the run. Ladies and gentlemen, in this picture, what is the rise of the ramp? 80. What is the run of the ramp? X. What is the slope of the ramp? 1/8. So what do we need to do? Let's just make 80 over x equal to 1/8 and solve. Go ahead, solve. Solve, solve, solve. How do you solve? You do many ways. You like fractions? Go ahead. You want to cross multiply? That's fine too. See if you get the answer. You can use your calculator if you need to. 6 what? 640. Good. 640 centimeters. Correct. Okay, ladies and gentlemen, I'd like us to modify your homework assignment. Can you please turn to the last page? And I'm going to ask you to do page 339, but let's just do up to number
Wait, what was it? 640?
640, yeah. Let's do up to number
15.
9.
49.
You know what? You could do all of them.
No,
That's not right? Okay, fine. Do everything up to 26. You don't have to do the challenge.
that's basically everything.
What a deal.